In our previous lessons, we've been working with different probabilities, and we've talked about whether things were independent or not before, and so by definition, we know that two events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. So what we're going to look at today are the events female and preferring English independent. So normally what we do is we collect our class data and fill in our two-way table and our Venn diagram just like we did our previous lesson. So we're going to use the previous year's data to help us. And so I asked students to come up to the board and just place where they fall. And so we're looking at gender and whether they prefer English or math. And these were the results from the previous year. So if I take a look, I had 8 students that were female that preferred English versus 2 female students preferring math, 7 male students that preferred English, and 5 male students that preferred math. Remember, with your two-way table, you always want to do your totals horizontally and vertically. And so remember, the total number of people surveyed would always be in that total right-hand column. So we had 22 students take the survey. So what I'd like to do next is, based on the results for the two-way table, can you transfer them to the Venn diagram correctly? So we're going to pause the video, have you transfer your answers to the Venn diagram, and check and make sure you're on target. Based on the results for our two-way table, our Venn diagram should look like this. So we're comparing the females to English, right? And so females, we want to look at this section here is how many females prefer English. That was 8 versus just 2 other people that did not in that female category. How many people preferred English but weren't female? So this is my male English preferred section. And then the ones that would not fit either category, female or English, well, that would be the males that prefer math, and that's how we're getting this value here. Now that we have the data represented in our two-way table and our Venn diagram, we're going to answer some questions with probabilities. So now we want to suppose that we randomly choose a student from the class, and we want to find the following probabilities. So based on the descriptions here, let's have you write the probabilities. So we're out of 22 students. Don't worry about simplifying the fractions right now. Let's just figure out what are the chances that these items occur, and then we'll go from there. So we're going to pause the video at this point. Let's have you answer those questions with your pencil, and we'll resume the check to see if you're on target. So the probability of selecting a female out of the class, well, we had 10 females, so 10 out of 22 would have been our probability there. The probability that you preferred English, those that preferred English, was a total of 15 out of the 22. The probability that you were not female in the survey, well, that ended up being 12 out of 22. The probability that you did not prefer English, well, that was 7 out of 22. The probability of being female and preferring English class, that was 8 out of 22. The probability that you preferred English and were not female was 7 out of 22. The probability that you were female and you did not prefer English, that was 2 out of 22. The probability of not being female and not preferring English was 5 out of 22. And lastly here, find the probability of being female or preferring English. This one, we have to stop and think about what we're working on, right? The probability of being female or preferring English, we might have some people that classify for both of those events. So the probability of female was 10 out of 22, and the probability that you preferred English was 15 out of 22. However, some of those females preferred English, so we have to take away those that would be double counted, the 8 out of 22, right? These were the 8 females that preferred English. So that leaves you with 17 out of 22. Remember in our previous lessons when we were talking about the chances when we're using with or versus and, we have to see if they are mutually exclusive or not. If they are mutually exclusive, we don't have to worry about double counting going on. But if they're not, then we do, and we have to subtract the probability of both events occurring at the same time. So that's what that 8 out of 22 represented. Now let's continue on and look at a couple more probabilities that could occur. It says, what's the probability that a student prefers English given that they are a female? And here we want to write it as a percent. Now this is worded a little bit differently than what it was before. It says, what's the probability that the student prefers English given that they are female? Well, we are being told here that we're only working with the females for the survey. So this changes things a little bit. Given that you have a female, we had to look to see, well, how many females were surveyed, which ended up being 10. And of those 10, how many preferred English? That ended up being 8. So what would that look like with our probability notation? Well, we're saying that we are looking for the probability that a student prefers English given that they are a female student. So notice how here, when we're talking about the probability notation, it looks like P, and then you have your first and second events, right? Well, our first event is given that they are female. So it kind of looks like it's to the right of that bar. And then what part are we looking with? Those that prefer English. So again, we're looking for the chances that both things are occurring given the event that has to occur. So given that they are female, the 10, how many were female and selected English? So that would be 80%. So there is a condition for this probability. That condition was given that they are female. Our next question is, what's the probability that a student prefers English given that they are a male? And again, write it as a percent. So here, what's going on? We have to recall that we have some stipulations. It says, given that they are a male, so we're reducing our sample size, right? We want to look at how many males were part of the survey and what would be the probability of those preferring English. So probability-wise, remember, this is what the notation means, right? Find the probability of the students that prefer English given that they are males. So for us, that ended up being 7 out of 12, which is 58.3 repeating percent. So it's 58 and 1/3% chance that this occurs. Again, conditional probability. Given that they were males, what were the chances that they preferred English? Lastly, it says, are the events being female and preferring English independent or not? So what does that mean? It's saying that if I know whether or not a person is female, does that change the probability that they prefer English? Well, based on our results, if we look at being female and preferring English and not being female and preferring English, you can see a difference there. We also can look at just those that prefer English in general compared to that one given category being female. And so if we think about that, we're kind of seeing does one influence the other. For our purposes, there were 8 out of the 10 females that preferred English. That was drastically changing our results versus knowing the total that preferred English, right? So it drastically increased it. So it is a dependent event. So when we're checking for independence or not, we're trying to see if these events have influence or not. So again, given that one event occurs, is that influencing the first one, similar to what we did before, or if that event's not occurring, what are the chances of that happening again? Remember the not occurring, the C, we talked about the complement. When it's in that exponent, that means it's not occurring from our previous lessons. So let's see what our big ideas from today are. One, we talked about conditional probability. So again, if we see that notation kind of like P, and inside the parentheses we've got A/B, we read that as the probability of event A occurs given B occurs. So it's typically reducing your total, that sample size that you're looking at. If you want to look back at our previous notes, when we're talking about the survey from last year, that's going over like numbers 4 and 5 again. And so I've got you the explicit formula to represent it and the meanings. Again, probabilities can be written as a fraction. We could simplify that fraction. We can write it as a percentage. We can write the percentage as a decimal. All of those results are equivalent. We just have to see what the question wants for the answer. The other part we were talking about was independence. So knowing if an outcome of one does not change the probability of others. So if there is no change, if I calculate the probability of event A happens given B, and the probability that event A happens when B does not happen, and they're equal, they're independent. If they're are not equal here, right, when B is not occurring versus when it is occurring, that would show that it is dependent. So again, that's going back to number 6. So we were looking at when A occurs given B, that was the 8 out of 10. That was what, 80%? And then given B not occurring, that was the 22. Of those preferring English, that was 15, that's 68%. They were not equivalent, therefore it had to be dependent events. So based on our activity today, you're going to take a look at your application for 4.4, and you have your two-way table established here. Remember, always, with your tables, whether they're two-way tables or three-way tables, four-way tables, you always want to extend the sides so you can look at totals to help you look at your probabilities. Notice how a lot of this is in your probability notation here, so you can go back and think about, well, what is the meaning of that with those big ideas? And then always interpret it in context. So you want to write a sentence to say, once you found the probability, what does that mean? If you want to write the probability as a fraction, that's fine. If you want to do a simplified fraction or a decimal, all of those are okay. And we'll take a look at the results during our next lesson.